Hello guys, what's up? This is Sir EJ and welcome again to another math tutorial. In today's topic, we will be discussing the union and intersection of events in probability. These are the following objectives we need to attain in today's topic. At the end of the lesson, the students should be able to Letter A. Illustrate the probability of a union and intersection of two events. Letter B. Find the probability of a union and intersection of two events. And letter C. Appreciate the relationship of the union and intersection of events in real-life situation. Let's have first our preliminary activity. 110 grade 10 students from General Emilio Aguinaldo National High School are interviewed if they are willing to join either volleyball or basketball in the upcoming Sports Fest. Shown here is the result of the survey. So we have the following table. So we have the sports, the number of students who did join the volleyball is equal to 22. Basketball is equal to 44, and the number of students join both sports, volleyball and basketball is equal to 33. The next step we need to do is we need to construct a Venn diagram. So there are 110 G10 students of General Emilio Aguinaldo National High School, which was interviewed whether they will join volleyball or basketball. So 22 answered volleyball, 44 answered basketball, and 33 answered both. So the first thing we need to do to construct a Venn diagram is to create or sketch a rectangle here. And then after that, we will draw two circles. These two circles represent the two sports that the student will play. One for volleyball and one for basketball. And then after that, we will put 33, which is the students who will join volleyball and basketball in this portion. So the portion wherein the two circles overlap with each other. And then after that, we will put 22 volleyball, the number of students who will join volleyball here in this portion of the circle. And then we will put 44, the number of students who will join basketball in this portion of the circle. And then after that, we will check if the number of students that is already given is equal to 110. And with that, we will add these numbers. We will add 22 plus 33 plus 44. And then adding these numbers, 22 plus 33 plus 44 is equal to 99. So it is not yet equal to 110 because there are 110 G10 students. So what we need to do here is we will subtract 110 minus 99 and we will get 11 students. So these 11 students did not join volleyball or basketball or volleyball and basketball. So we will put 11 students outside of these two circles. So we will put 11 here. So this is what our Venn diagram looks like. Let's try to answer the following questions. What is the probability of the students who are willing to join volleyball? To solve for the probability of the students who are willing to join volleyball, we will apply the probability of simple events, wherein the probability of event E equals the number of event outcomes over the total number of possible outcomes in the sample space. All we need to do here is to get the number of event outcomes. To get the number of event outcomes, we will just add the number of students who will join the volleyball. We can get the number of event outcomes by adding all the numbers inside the circle of volleyball. So, because we will get the probability of the students who are willing to join the volleyball. So, we will look at the circle, or we will look at the number inside the circle of volleyball. So, we have 22 and 33. So, we will add 22 plus 33, and then to get the total number of possible outcomes in the sample space, we will just add all the numbers. So 22 plus 33 plus 44 plus 11 is equal to 110, or it is already given in our problem. So we have 22 plus 33 is equal to 55 over 110, and then lowest term 55 over 110 is equal to 1/2. Therefore, the probability is equal to 1/2, or there is a 50% chance that the students that will be interviewed will be joining the sports, which is volleyball. Let's have our next question. What is the probability of the students who are willing to join volleyball only? So we will again use the formula of the probability, number of event outcomes over the total number of possible outcomes in the sample space. And we will determine the number of students who will be joining volleyball only. We will look at this circle because it indicates the students who will join volleyball. But this time we will only get 22. We will only get the number 22 for the number of event outcomes because we are looking for the students who will join the sports, which is volleyball only. So we will not include 33 because 33 indicates that these students will be joining both basketball and volleyball. So for the number of event outcomes here will be equal to 22 over 110. And the lowest term of 22 over 110 is equal to 1 over 5 or 0.2. Therefore, the probability of the students that will be interviewed that will be joining volleyball only is equal to 1 over 5. Next question, what is the probability of the students who are willing to join basketball? So to do that, we will be using again the formula of simple probability, and we will determine the number of event outcomes. So we are looking for the probability of students who are willing to join basketball. So we will look at the circle which indicates basketball. So this is it. This is the circle. So we will be adding the numbers inside the circles of basketball, and that is 33 and 44 for the number of event outcomes. 33 plus 44 over the total number of outcomes in the sample space is equal to 110. 33 plus 44 is equal to 77 over 110, and getting its lowest term is 7 over 10 or 0.7. Therefore, the probability that the students that will be interviewed that is willing to join basketball is 7 over 10. Next question, what is the probability of the students who are willing to join basketball only? So using the formula of simple probability, so we will look at the circle of basketball in which we will get the number of students who will join basketball only. We will not include 33 again because 33 indicates the students that will be joining volleyball and basketball. So we will just get 44. So the number of event outcomes is equal to 44 all over the sample space, which is the total number of G10 students that was interviewed. So we have 44 over 110, and the lowest term of 44 over 110 is equal to 2 over 5 or 0.4. Therefore, the probability of the students that will be interviewed that will be joining basketball only is equal to 2 over 5. Next question, what is the probability of the students who are willing to join volleyball or basketball? So to solve for this, we will be using again the formula of simple probability, and we will be getting the number of event outcomes and the total number of possible outcomes in the sample space. Let's first get the number of event outcomes. So for the number of event outcomes, we are looking for students who are willing to join volleyball or basketball. So we will be adding these numbers inside the circles of volleyball and basketball to get the number of event outcomes. So it will be 22 plus 33 plus 44 all over 110. And adding these numbers, 22 plus 33 plus 44 is equal to 99 over 110. So 99 over 110 is equal to 9 over 10 or 0.9. Therefore, the probability of the students who are willing to join volleyball or basketball is equal to 9 over 10. We have our last question for our preliminary activity. What is the probability of the students who are willing to join in basketball and volleyball? We will be using again the formula for simple probability, and we will be getting the number of event outcomes. So the event outcomes are the students who are willing to join in basketball and volleyball. So the students who will be joining both basketball and volleyball is equal to 33, or there are 33 students who will be joining both sports. So the number of event outcomes will be equal to 33, and the total number of possible outcomes in sample space is equal to 110. And the lowest term of 33 over 110 is equal to 3 over 10 or 0.3. Therefore, the probability of the students who are willing to join in basketball and volleyball is equal to 3 over 10. With that preliminary activity, we have learned, or you have learned, how to compute or how to solve probability using a Venn diagram. And also, some questions that I have given to you already introduced you to our topic for today, which is this example. So what is the probability of the students who are willing to join volleyball or basketball? So in this problem, this illustrates the union of two events. So if there is a word or in the problem, it indicates union of two events. Now, what is union of two events? As you can notice, to get the probability of students who are willing to join volleyball or basketball, we all add the numbers inside the two circles of volleyball and basketball to get the number of event outcomes. Now, what is union of two events? The union of two events is a new event that contains all of the outcomes that are in at least one of the two events. The probability of the union of events A and B, denoted by probability of A union B. So we have the formula, probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So this is our formula to get the probability of the union of two events. Now, in this problem, what is the probability of the students who are willing to join basketball and volleyball? This also shows new concept that we will be learning for today, and that is the intersection of two events. Now, if we can see the word "and" between the events basketball and volleyball, then it shows intersection of two events. To get the number of event outcomes, we will just get, or we will just look at the portion in which the two circles overlap with each other, which is this portion, and that is equal to 33. Now, what is intersection of two events? When we say intersection of two events, the intersection of two events is a new event that contains all of the outcomes that are in both events, and the probability of the intersection of events A and B is denoted by probability of A intersection B. Let's apply the concept of the probability of union and intersection of two events with the following problems. Max rolled a fair die and wished to find the probability of the number that turns up is even or number which is greater than 3. Now, we will be looking for the sample space and the event outcomes. Sample space is equal to 6. There are 6 numbers which is located in a pair die or 6-sided die, and those numbers are 1, 2, 3, 4, 5, and 6. And we will get the event outcomes for the event A, which is the probability of the number that turns up is even, which are the numbers 2, 4, and 6. And the event outcomes of the number which is greater than 3, which are the numbers 4, 5, and 6. After that, we will get the intersection of A and B. A intersection B are the numbers which is the same with set A and set B, which are the numbers 4 and 6. We have 4, 4, 6, 6. So A intersection B are the numbers 4 and 6. Or you can illustrate it on a Venn diagram to see it clearly. So we have event A, we have 2, 4, 6. For event B, we have the numbers 4, 5, and 6. And their intersection is 4 and 6. The numbers 1 and 3 are outside of the two circles, right? After that, we will be using the formula for the probability of union of two events. So we have probability of A union B is equal to the probability of event A plus the probability of event B minus probability of A intersection B. And all we need to do is to get the probability of event A. So we have the number of event outcomes, which is 3. We have the numbers 2, 4, 6. So we have 3 for event outcomes over the total number of sample space, which is equal to 6 because there are 6 numbers in a die. So we have 3 over 6 for the probability of event A plus the probability of event B. We have the possible event outcomes, which is 4, 5, 6, which is equal to 3. All over 6 again, the total number of sample space, minus the probability of A intersection B. So for A intersection B, we have 4 and 6, which is equal to 2. All over the total number of sample space, which is equal to 6. So that is 2 over 6. And then after that, we will just simplify. So this is an example of similar fraction. Therefore, we will just copy the denominator, which is equal to 6, and then add and subtract the numerator. 3 plus 3 is 6. 6 minus 2 is equal to 4. So we have 4 over 6, or lowest term, is equal to 2/3. Therefore, the probability of the number that turns up is even, or number that is greater than 3 is equal to 2/3. Let's have our next problem. Max rolled a pair die and wished to find the probability of the number that turns up odd or even. So to do that, we will be identifying the sample space. On a 6-sided die, we have 6 numbers. The numbers 1, 2, 3, 4, 5, 6. Therefore, the sample space is equal to 6. And then after that, for event A, which is the odd numbers, which is located in the sample space. So we have 1, 3, and 5. And for event B, the even numbers. So we have 2, 4, and 6. And then after that, we have A intersection B. What are the numbers which is located in event A and event B, which is the same? So we have none. There are no numbers which is the same with event A and event B. So we have a null set. And then you can draw a Venn diagram here. So we have two circles. For event A, we have the numbers 1, 3, 5, which is the odd numbers. For event B, we have the even numbers 2, 4, 6. And as you can notice, there is no portion wherein the two circles overlap with each other. So we will be using the formula of union of two events, this one, and we will be getting the probability of event A. Event outcomes for probability of A is equal to 3. So we have 1, 3, 5. So we have three odd numbers all over the sample space, which is equal to 6. Plus event B, probability of event B. So we have 2, 4, 6, 3 event outcomes all over the sample space, which is again equal to 6. Minus, we have a null set, A intersection B. So we have 0 all over the sample space, which is equal to 6. This is an example of similar fraction. So we will just copy the denominator, 6, and then add the numerator, 3 plus 3, 6. 6 minus 0, 6. So we have 6 over 6, and dividing these two numbers, 6 divided by 6 is equal to 1. Therefore, the probability of the number that will turn up is odd or even is equal to 1, or 100%. Certain probability. Let's have our next example. Max rolled a fair die and wished to find the probability of the number which is divisible by 5 turns up, or the number of odd number turns up. So we will be identifying the sample space. Again, on a die we have 6 numbers, so the number of sample space is equal to 6. And for event A, we will be looking at the numbers which is located on our sample space, which is divisible by 5. And that number is 5 only, because 5 divided by 5 is equal to 1. So the number which is divisible by 5 is only 5. So for event A, we have one sample space. How about event B? So event B, the number of odd number turns up. So for event B, we have the numbers 1, 3, 5. These are the three odd numbers which is located on our sample space. And then after that, what is the intersection of A and B? So the intersection of A and B, they have the same number, which is 5. So we have 5 here. So A intersection B is equal to 1. There is only one number which is the same in event A and event B. And you can draw a Venn diagram here. So we have two circles, and then we have the numbers 3, 1, and 5, and they have both 5. So this is their intersection. And the numbers 2, 4, and 6 are just outside the circle. And we will be using the formula. We have the probability of event A plus probability of event B minus the probability of event A intersection B. So we'll be substituting. We will be getting the probability of event A, which is the total number of sample space, which is equal to 6. Event outcomes, which is 5. So we have one number, so this is 1. Plus the probability of event B. We have the sample space, which is equal to 6 again. And then the event outcomes for the probability of event B, which is equal to 3. The numbers 1, 3, 5. There are 3 numbers. Minus probability of A intersection B. So event outcomes of intersection of A and B, which is equal to 5. So we have only one number. So this is equal to 1. All over again to the sample space, which is equal to 6. This is an example of similar fraction, so we will just copy the denominator 6 and then simplify the numerator. 1 plus 3 is equal to 4. 4 minus 1 is equal to 3, and that is equal to 3 over 6. And the lowest term of 3 over 6 is equal to 1/2. Therefore, the probability of the number divisible by 5 turns up, or the number of odd turns up, is equal to 1/2. There is a 50% chance of getting that number.